Here we have our worked example 2 of the same case where we have a polynomial function, okay? We don't care what it's multiplying. It can multiply any other function except for the logarithmic function, of course, like we said. But here, whenever it multiplies any other function in our Lipit list, then we are going to make the polynomial function u. So here we already have it. We have this algebraic term multiplying the exponential. So what is going to be u? Of course, the algebraic. So you say, let u be equal to 3x squared, because we said is the one that gets it, right? Then, what is going to be your du dx? The derivative with respect to x is going to be 6x. All right, and that means du is going to be 6x dx. Okay, dx goes the other side, right? Not a problem. Now, that means my dv, never forget the by parts formula. I think it's best you always write it. u dv is equal to uv minus integral of v du. Okay, so that's it. You start with the first one, as it is u dv, all right? Okay, so it's fine. What is my dv? My dv is equal to e to the 4x. And we can say v is equal to the integral of e to the 4x with respect to x, because it's a function of x there. So, and what is that? That means v would be, you must be good at this, right? Okay, so this doesn't change, e to the 4x doesn't change, but then you divide by the derivative of the power. The derivative of 4x is 4. If we were differentiating, we would multiply by the derivative, but here we divide, okay? So that's kind of what it is. So now if we put it there, would be now saying the integral, therefore, the integral of 3x squared e to the 4x with respect to x is equal to, what is my u? My u is 3x squared, and it's multiplying my v. My v is e to the 4x divided by 4, and we subtract the integral of v. What is my v? Is still e to the 4x divided by 4. Now it's multiplying du. What is my du? Du is 6x with respect to x. Oh, really? Yeah. So what am I going to have? I have the integral of 3x squared multiplying e to the 4x with respect to x. Now being equal to, here I have this 4 dividing, I can just take it to the front. So it'll be now 3 over 4 x squared e to the 4x, okay? And then minus, you can put out the, here we have the constant 1/4, you can put it out, or you can make it 6 over 4, right? You'll be having, and pull it out. So you can have 6 over 4, you pull it out, you'd have e to the 4x x dx. And I can rewrite that and say x, then e to the 4x. That's up to me. So I can do that. I would say this would be x multiplying e to the 4x with respect to x, the integral. And here again, I see that I must do by parts again, and I would say let u, okay, again, it's now another by parts, I would have to do it, okay? So I could say let u2 be equal to, again, the algebraic, of course. So it's equal to x. That would mean du dx is equal to 1. And that would mean du is equal to 1 dx, isn't it? And therefore, I'm calling it u2 because it's kind of like the second time I've used it, but you can still call it u. Then you could have, of course, your dv being equal to e to the 4x. And again, you know v is the integral of e to the 4x with respect to x. So that means v would be equal to e to the 4x over 4. And you can now put the things again. You can call it v2, it's still fine. The integration by parts formula still applies, so it's going to be integral of 3x squared e to the 4x with respect to x is equal to 3 over 4 x squared e to the 4x, right? Minus 6 over 4. Now 6 over 4 is going to multiply what's about to come now. Okay, we have this integral of x e to the 4x. We have now done it by using the by parts again. It would now be uv minus v du, integral of v du. What is your u? It's x. So it's x times, what is your v? Your v is e to the 4x divided by 4. And then minus now the integral of v, and that is again e to the 4x over 4 du. Du would be 1 dx, which is just dx, okay? And all this is being multiplied by 6 over 4. So sorry for crowding the work here, okay? It's kind of like a degree separation here. Now we can continue. Oh, that would mean that we had to do by past twice, isn't it? So that means that here we now have 3x squared e to the 4x dx being equal to 3 over 4 x squared e to the 4x minus, here I have x multiplying e to the 4x divided by 4. This is multiplying 6 over 4. So if I'm dividing by 4, that means 4 is going to go again in my denominator. And my denominator will now become 4 by 4. That's 16. So it'll be 6 over 16 x e to the 4x. This x, okay. And then e to the 4x. Then you can have again, here you have now the integral. So you could say it's minus 6 over 4 multiplying, what is the integral of e to the 4x divided by 4? That integral, the integral of e to the 4x, so we take out the quarter, it would be 1 over 4 outside, then we have the integral of e to the 4x dx, okay? Because we had to pull it out. So if I take out the 1/4, I do multiply the 4, and I would be having minus 6 over 16 integral of e to the 4x dx, and this just becomes minus 6 over 16 multiplying e to the 4x over 4, right? Remember, over 4, that's the integral of e to the 4x. And because we have reached the end, we now add the constant of integration c. So here you would have to write everything again, and here I can say the integral of 3x squared e to the 4x dx is therefore equal to 3 over 4 x squared e to the 4x minus 6 over 16 x e to the 4x, then minus here again 6 over 16 e to the 4x over 4 plus constant of integration c. Wow, really? Yeah, and that's how it goes. So here we can finally say that you can have your marks. We are complete. You have done here. You've done it all. So here we can say 3x squared e to the 4x dx would be equal to, here we have 3 over 4 x squared e to the 4x minus 6 over 16 is like saying 3 over 8 x squared e to the 4x. Then here it'll be 6 over 32, over 64 rather. 6 over 64, and if we divide, that would become 3, so it'll be minus 3 over 32. Okay, 6 over 64 is like 3 over 32 e to the 4x plus constant of integration c. I hope you saw what I did there. So yeah, that's just what it is. If you want to take out e to the 4x, you can, and be left with some of these values. Okay, this is 3 over 32. And this would be your final solution. You could leave it in this case, which I think is fine. And that'll be your final solution to this example.